So it's 3 p.m. At least it's 3 p.m. for me in Central in UK time. I don't know what time it is for everyone else, but I think we can get started. So welcome everyone to this this second webinar in this HUPO, the Human Proteome Organization, ETC. That's the Education Training Committee Auditorium webinar series. And the goal of this series really is to help the proteomics community to improve their ability to for scientific communication and for writing skills. And so this is the second edition, as I mentioned. First edition, we had John Yates, Editor-in-Chief of Journal Proteomics, talking about scientific writing. And today we're very lucky to have Martin Krzywinski with us. So my name is Ben Collins from Queen's University, Belfast. Joining me on the panel today is Yansheng Liu from Yale University School of Medicine and Taekyu Lo from UKM Medical Molecular Biology Institute. And as I mentioned today, we're very honored to host Martin Krzywinski, who is based at Canada's Michael Smith Genome Sciences Centre in Vancouver, BC. And so Martin works in bioinformatics, in data visualization, science communication, and at the interface of science and art. And his figures and graphics have appeared in the New York Times, Wired, and on the covers of books and scientific journals, including Science, Nature, PNAS, and actually too many other more journals to mention. Martin is also notably one of the main authors of the Points of Significance and the Points of View series that many of you will have seen in Nature Methods, which I think is a great resource to explain many key statistical and experimental design concepts, as well as advice on how to create effective figures. And so I think we're very lucky today to have one of the leading experts in data visualization for biology with us. So I think what we're aiming for is that Martin will talk to us for around approximately 40 minutes about his ideas for data visualization. And then in the second half, we have the opportunity for some Q&A. And I think some of you also were able to submit some figures to Martin's Dropbox that he advertised, we sent around with the advertisement. And so that hopefully there'll be an opportunity to discuss a few of those. And so Martin's topic today is the essence of data visualization, how to create effective figures of your data. So with that, I think I will pass the ball to Martin, if that's fine, Martin. Please feel free to...
That sounds good. Thanks so much.
Share your screen, and I think the rest of us can drop off the video and so on. Thanks, Martin.
Thank you. Okay, welcome everyone. Thanks for joining. My goal today will be not as much to demonstrate specific rules of how to create graphics, because there's a lot of data types out there, and there's a lot of ideas out there, and it may not match everyone's workflow and not match everyone's field. But I want to take the time to make you think differently about graphics. Because I think in about 40 minutes of talking, you'll get more out of it if I can try to reframe some of the foundations of how to organize yourself on the page than if I were to just tell you what to do very specifically. That being said, I will say some things that you should and should not do very specifically. So I'm going to try to answer some questions that I asked myself, which is what makes a good graphic? Regardless of whether it is a graphic that is scientific, regardless whether it is a graphic meant for experts or for the public, it is generally going to be a graphic that is trying to explain something, meant for someone who knows less than the creator of the graphic. Always keep that in mind. And so one of the main reasons why graphics are good is that when I look at a graphic, I know why it exists. In other words, the design embodies its purpose. I don't know what the message necessarily means. That is up to the speaker, that is up to the legend, perhaps that is up to the copy of the text, but I know what the message is. So let's look at this graphic. Why is this graphic on the screen? What is this graphic trying to tell you? You've seen this kind of stuff on posters. This comes from a poster, right? It's clearly a control and some experimental intervention, and there's a difference. But what are the differences that are worth looking at? I want to know. I want to know that before I read the legend. Is it the fact that there's a second peak here? Is it the height? What are the differences? Suppose it's the area of the second peak versus the first peak. In fact, that's the case. Why not then fill out the area underneath the curves to clearly show what it is that you're supposed to be looking at? Now, the graphic is starting to take on a purpose that is more clear. Notice that the original data is shown, but the things we're meant to get out of the graphic are highlighted. They're more salient. A graphic should also help you make good judgments about the quantitative data, the ratios and the differences in quantities which are mapped onto lengths or whatever. So, for example, instead of just filling in the areas under the second peak, I might then say, I want to help you assess the areas better than you can by eye by showing you what the area actually is with a quick bar chart. The bar chart is horizontal, it's nicely aligned with the curves. Blue is the intervention, gray is the control. Always a great way to identify what the baseline is by using gray, and then some kind of a color to indicate the intervention. Typically, what I like to do is I use kind of primary magenta. It stands out quite nicely. Blue is also good if the result is positive. Sometimes in medical science, if the outcome is bad, you might want to use a color that is more alarming. So something towards the red, but not pure red. The bar chart doesn't have a lot of tick marks. There aren't a lot of numbers there to tell you what the values exactly are. And I do this on purpose. What I'm trying to say is that's not that important. Because the tick marks aren't there, it's not that I left them out accidentally. It's that I just want you to assess proportions better. And I put 50% in as some number. This is hand-wavy values to tell you maybe there's a threshold that's important. The peaks that are larger than that take on a different meaning. And then a graphic should try to anticipate what the questions are that the reader has, because the data will not speak for itself, and anybody who says that often hears the wrong message and presents the answers to those questions. So for example, you might say, well, what is the ratio of the areas? That might be important. So I provide that as a value. And notice I don't say things like ratios of areas or proportion of curve area of control over intervention. The heading of the column is just blue square over gray square. It's clear what that means, right? You see that as a ratio, and the numerator and the denominator are kind of like a figure legend. You don't need to use words at all in this graphic, other than perhaps the intervention and the word control. And maybe when you attended the writing seminar, a webinar, there was some mention of being concise and using plain words where possible, as opposed to flowery jargon, which sometimes is necessary when it is a technical term, but often it is not. A graphic should also have an axis, generally, if at all possible, because there often is some kind of an axis along which the important quantity evolves. This could be time, this could be distance, this could be something related to your system. Because when you have an axis, if you think about it, it can act a bit like a row or a column of a table. And when a graphic becomes more tabular, it helps you get organized, because while a table may appear as very dry and difficult to parse, which is true if it's full of numbers, the rectilinear aspect of a table that lines things up is an incredibly useful feature of the table that you should try to borrow from in graphical formats. So let's look at this graphic. If you're not a genomicist, that's fine. It doesn't really matter because this is just about chromosomes being added. There's a gain of a chromosome in this particular kind of event chain. There's a gain of a orange chromosome, then there's a duplication, whole genome duplication, where each chromosome is duplicated. So from 3 we go to 6, and then there's a loss of a chromosome, fair enough, which results in 2 greens and 3 oranges from 1 green, 1 orange. And then there's this other route where we go from the same start point, 1 green, 1 orange, we wind up at the same end point, but we go through a whole genome duplication and a gain as opposed to 3 steps, okay. This is very clear, right? This is not that complicated. However, this figure doesn't really scale. What if there were more processes that were longer chains? But even though this figure is easy to understand, it provides a great opportunity to practice kind of what you have learned about arranging things like a table, because if you can get simple figures right, amazingly right, just pristinely, then when you come to a complicated figure, you'll be well equipped to deal with it. But if you look at simple figures and go, that doesn't matter, that's too simple for me to worry about, everybody will understand it. You will defer working hard on a figure basically until never, because you'll always go, well, that figure is too simple, I'm not going to work on that. Always try to practice with simple things, because actually simple things can be quite difficult, because really the rules are little sets of rules that you just repeat. And so if you could get the right little things, you just repeat them and you fix bigger things. So why not arrange the chromosomes in a way that allows us to compare the gain and loss of chromosomes vertically, because then the number of chromosomes is arranged horizontally. And so we immediately see the number and how many more there are. There's also this importance of alignment to emphasize differences. So why not put the paternal alleles chromosomes and the maternal chromosomes on either side of a vertical line to more easily figure out how many of each there are and how many of each there are more of. So notice that on this side, the chromosomes were not particularly aligned along vertical lines, whereas here they are. So this is an important way of organizing yourself. Everything has to be aligned. Everything has to be on the page according to some rule. It should not just be thrown on the page. Now, when you write, it's a serial list of words, right? Word order is important. There's a reason why in a word order a word is in this position of the sentence and not some other one. It does matter. You wouldn't say, oh, it doesn't really matter. On the page, we do a bit more error checking, but the same rule should apply. A good figure encapsulates detail and shields the viewer from unnecessary detail that has nothing to do with the message. So do I really need to draw a very complicated chromosome, or can I draw the simplest chromosome that I can kind of think of? This is one way of doing it, where the chromosome is a lot smaller, the text is a little bit bigger, and the colors, I go with gray and pink, but it doesn't really matter. But typically I try to use less color than more because it gives me room to use more color if I need to. There's this also thing in biology, there's a lot of visual tropes, meaning that you've seen chromosomes drawn as the ideograms with the centromere. And so you just keep drawing that because that's what you think a chromosome looks like. And that's what you think people need to see when they think chromosome. And if they don't see that, they won't think chromosome, which is not particularly charitable to your audience. Proteins and all sorts of things like this, people have a sense of what they must look like. And often these are legacy decisions that are not the best ones. So don't always think that you need to show it how it is, because here about chromosomes, we're talking about entities that duplicate or become lost. So why not draw it as this kind of tree? Notice when I do this, the loss of a chromosome is really obvious because it's a dashed line and there's no chromosome at the end of this line, so it's clearly missing. And you get a sense of the duplication much better when it's drawn as a table, because these lines correspond to a copy. The label gain, duplication, loss is right next to the process, and you can follow things up to down and see the difference right away. And you can quickly see that this happens in 2 steps, and this happens in 3. Okay, finally, as I try to simplify this figure, a figure needs to know when it's not needed, okay? In other words, this figure can be expressed by very trivial arithmetic. In other words, if we start with n chromosomes, we gain 1 plus 1, we duplicate everything times 2, and then we lose 1 minus 1. In the parsimonious step, we duplicate everything 2 times n, and we gain 1 plus 1. And you'll discover that these quantities are exactly the same when you unpack them. And so why not just do this? And you're thinking, oh, but people don't want to see math. But really, they don't want to see math. We're doing complicated science in 2023. They can deal with a little bit of arithmetic. Don't pander to your audience's fear of seeing things that are too complicated. First of all, it's not complicated. If somebody says this math is too complicated, you've got to ask them, where did they go to school? Secondly, challenge them. And the reason why people don't want to see things that are complicated, because they typically are explained poorly. They know the speaker isn't going to do a good job. And so they're like, just show me a picture and you can stop talking and I'll try to figure out myself. That's not a good way to get forward. So rearranging patterns is very important because often software won't do this for you. So here's a graphic. If you use R, you know this was made by R. It's a facet plot because this is the default setting in R. Why are we looking at these data? I don't know. The data visualization is fair. It's a fit of data. Sometimes maybe the fit is a little sketchy, but whatever. There's some compounds and they're ordered in what way? I don't know. What should I be looking for? I don't know. I'm waiting for the speaker to tell me. Does the legend tell me? Nope. The legend tells me nothing about what kind of patterns I'm expecting. But what if I just do this? What if I order these based on the change in the shape of the fit as I see by eye, create some kind of a pattern? Now you know why you're looking at these, right? Now you know that probably this peak that's forming is pretty important. And then this chemical is really strange. It has 2 peaks, and this one doesn't kind of go back up. So automatically, just reordering things creates a grouping. Software will not do this for you. Whenever you see panel A, panel B, always ask yourself, why is panel B second? Whenever you see a bunch of plots, always think about rearranging things to, again, express why the figure exists. If I wanted to add more detail, I might say it's the year 2000 was important, so I'll draw a dashed line. So now you get, oh, the year 2000 was important. I should be paying attention to that year. If there was something about the position of this peak and this valley, and did it happen before the year 2000 or after the year 2000, I could express this visually. And you could look at this and go, yeah, I think I can kind of understand it. The red bars probably mean something. The blue bars probably mean something. I could probably figure it out. The fact that this first peak is red, that probably means something. And I'd be waiting for some story to focus on these points. Yeah, the default setting. So I complained about that figure because it's a default setting in R, and some people maybe don't like R, including myself. And when you get something working, you're so happy that you just don't want to touch it anymore because fiddling with it can break things. So do not be satisfied by the default settings in the software, and a lot of graphical output is actually default settings, be it a very ill-fitting template for a poster, or some kind of a graphic, where there's one trace and there's a legend that tells you what the trace is, and there's only one item in the legend, and is the legend necessary, that kind of thing. So again, I mean, I don't mean to make fun of R, although I kind of want to. Here's a plot. It's fine. It's box plots. There is a data distribution underneath. You get a feeling that, okay, I'm being shown information. There are p-values. Okay, I can kind of get my way around. But this figure suffers from silent diseases. And that is, I can't really tell what the data distribution is telling me. I mean, it's a blur. The more data points there are, the harder it is to see the median. In fact, here it's really tricky. There isn't a lot of focus placed on the thing that I should be looking for, which is the differences in median. The p-values are expressed, in this kind of 3 significant figures in p-value. If you report a p-value to 3 significant figures, ask yourself, can I trust a notion of certainty or error to 3 significant figures? I mean, and how many significant figures does the actual data have? P-value should be 1 significant figure, at most 2. The 3rd figure is just not meaningful. So what would we do with this? Well, the first thing that I would do is I would just remove the boxes. And the reason why I would remove the boxes and then share the axis across plots is because that's the right way to do it. It provides continuity. And even though things are not in a box, this is still 2 very clear groups. I would remove the tick marks on the categories, because if you ask yourself, do I need this tick mark? Clearly not, right? So you're looking at something that's a visual trope that's left over from a default setting. And I'm removing the tick marks to make you think about, do I need this element on the page? Now, the tick mark isn't bothering anyone, I'm sure. Nobody looked at it and went, those tick marks, they have to go. They're tiny, but sometimes those things that are not necessary are actually quite large. So learn to spot unnecessary things on the page, remove them in your mind, and ask yourself, would the message change? Okay, so I removed the boxes. I expressed p as minus log p, much better. Clearly minus log 13, that's enough. That gives me a sense that it's quite significant. But then what I want to do is I want to highlight the differences in the medians more. So I'm going to make the boxes of the box plot a lot more salient. I'm going to use a bolder color for the experiment, and the wild type will be either gray or black. And I'm going to go from this kind of blurry 50% opaque, 25% opaque, overlapping data points to 100% opaque, very tiny data points that create this kind of pepper effect. And I'm going to put them behind the box. You could see detail here much more than here. The question is, do you need to see it? Yeah, if the data is normally distributed, probably not. Looking at the box plots, unless something is very strange going on, here, these are clearly asymmetric. If you just look at box plots long enough, you know that's an asymmetric box plot because of where the median is. But fair enough, you want to put the data in there. Put it behind, don't put it on top of the data. Okay, so there's a big difference between the two. Your perception of the information hasn't necessarily changed, your conclusions haven't changed, but this bottom redesign takes care of the placement of the thing that's important in front, the thing that's less important in the back. It doesn't show unnecessary elements. In fact, there's nothing that you could remove that could be removed, right? Every line, every dot is important. Here's another example of the same kind of thing. You're probably thinking, oh, that's R, so we're going to fix this. Yes. In a similar way, we might create a background, for example, to indicate some kind of a feature about this, perhaps maybe whether it's significant to 3 stars as opposed to 2, which would be gray. Tumor gets pink, normal gets black, right? Here, instead of this kind of legend on the side, I labeled the boxes underneath. These are violin plots. If you can bring the labels in closer to the data points, people will like you for it. And clearly, I don't need to label every single one, just the first one. And here are my titles, the gene name, p-value, okay? And then if I highlight the genes in pink, that probably means something, and that would be discussed somewhere in the legend. Right? So I'm going through the same example because I want you to get a sense that this kind of plot can always be dealt in this kind of way, right? Remove the boxes. But what I've done here also is the title of the plot. Now, this is not as appropriate for a paper where in a manuscript, a journal will have specific styles about what you can make the figure look like and what the title can be. So this would be more appropriate for a poster or a presentation where the title actually includes the legend, healthy versus cancer. And I don't have to specify what gray and pink are. I put it right up front and I do it white text on the color, which is kind of like what the violin plot is. Instead of this legend tucked off against the side. I like to know ahead of time what I'm looking at as opposed to looking at everything at the end. This kind of TCGA, TPM thing in a box, does this need to be in a box? No, I would just put that at the bottom, kind of as a postscript, tucked out of the way. People will see it. That's generally the least important part of the figure, but it's clearly visible if you want to see it. All right, I won't show you a fourth violin plot. Another very, very important thing about data graphics is that there's continuity. And in other words, I've already mentioned this when we were aligning the chromosomes, that any visual variation you create is due to the data and not carelessness. Please take that to heart. Everything must be in a place that is a function of either the data underneath the data point, or because you've placed it there for best comparison to other data point. Don't just throw things up. If you're cutting and pasting, sometimes software will paste in a slightly different position. Don't just leave it there. Move it to where you think it belongs. Okay, very simple, right? Hard to get confused with this. But again, it breaks these little rules all over the place that would serve you well if you followed them. Why is there no continuity? In other words, if the blue thing, the blue strand is important, why isn't it along the same horizontal line? Why is it go up and then go up here? And why are these arrows so thick? And what's the most important thing here? Why do I have so many vertical lines to indicate the base pairs joining between the strands? Do I need that many? Why are they not uniformly spaced? I don't know the answers to any of these questions. I can kind of guess. The person made this quickly in PowerPoint and thought, that doesn't matter. Nobody will get confused. Nobody will think this is a toothbrush. Of course they won't. But the point is that if you don't take care of the simple things and you don't make that natural, it will be too late when you get to the complex things, and you will feel stressed and you will spend more time on the graphic than you need to because you won't know what to do. By practicing on the little things, it'll become second nature, and you'll be able to knock these graphics out very quickly. So what I've done here is the guide strand, the black thing is along a horizontal line, right? There's continuity, which means that if this is a comic strip, on every panel, something happens, but the main actor stays in the same position, so you get a sense of what's going on around it. Okay, instead of Dicer cutting things up, so here comes Dicer, and here's the thing uncut, and here's the thing cut. Oh, how tedious. And the Pac-Man thing, that's a visual trope. No, don't do it. Just do this. Show me not the before and after, but the during, right? Dicer just cuts, and that's it. That's all you need to do. It's kind of the first thing you need to know is right after this is done, this happens. Then the little bits fall to the bottom. The arrows are gray and light. Don't think that the arrows have to be black and thick. Do not draw arrows that have such a thick line and such a tiny head. Use equilateral triangle heads that look in proportion to the width of the line, something like this. And if you want, and you're feeling frisky, add a bit of color, but ask yourself, okay, do I need this color? Why am I using the color? Is the color because I've run out of visual emphasis with black and white? Or is it because I think I need to make the figure more sexy and nobody's going to look at it unless it's colorful? If it's the first, great. If it's the second, you're pandering to people's inability to focus, and they probably don't want to be there. And it's a vicious circle of making things flashier and flashier and flashier. And somewhere along that line, the substance and the concision gets lost, perhaps forgotten. So this is important, right? Salience and relevance. Salience is the thing that jumps out, that thing that you see right away. Relevance is the thing you should care about. So make the thing that jumps out the thing you care about. So some kind of a molecular process, some kind of transcription, wild type, something's going on over here, and it's one of those spot the differences puzzles. Well, I don't know what the differences are. There's a lot of stuff going on. At least it's aligned, but it's a good idea with this. Here's the cell divided into two halves. The first half is scenario A, second half is scenario B. But there's a lot of duplication here. And so it'd be easy to kind of get lost in all the differences. And I'm not sure I spotted all of them. In fact, if my life depended on it, I'd want to take a good 10 minutes to make sure I miss nothing. Don't do that. Instead, show me the thing before in its full complicated glory. No colors needed, really, right? The labels tell me the thing that's different. And unless there's families of proteins and unless there's another theme running through the figure, don't use color. And then on the right are the differences. It's just the stuff that's different. And the X's just tell you this doesn't happen. This doesn't happen, so I don't need to show any of this. Transcription doesn't happen, so I don't need to tell you more details because you get all the details here. So you see these two hits, these two molecular consequences of some kind of mutation or whatever the lightning bolt is up here, right? So that's important. You can count two things are big consequences, whereas before, good luck counting it. So choosing your own scale. I'm going to go through this fairly quickly because it's an elaborate example, but here is a plot of methylation. And so you don't need to know what this means, really. You just need to know that the green, okay, there's a control, which is the green. Let's call that healthy. And then the orange is the disease, okay? And here's methylation values in some genes. And of course, because it's measured at different positions and in different genes, it's measured at different densities, you get this kind of plot where if you show things to scale, you'll get no data points here and a lot of data points here. And the question is, does this matter? What am I supposed to be looking at? Where are the patterns? What kind of comparisons should I be looking to make? I drew this now with a little bit more clear color scheme. So black is the healthy wild type, orange is the disease state, right? You still can't see anything. But what if I were to just draw the position of the methylation, of the points at which methylation was measured in as an index in order of appearance, regardless of where they were positioned? Now, this may or may not be a good idea for technical reasons, but I feel like it really doesn't matter, right? Because you're measuring the methylation in exons. I mean, do you just need to basically know where it's higher in the disease or lower in the disease? So here's an example. I think you get a sense of the variation in the data a lot faster. And you could do things now. So instead of, how do I focus your attention on the points, the orange points that are lower or higher than the black points according to some statistical test? Good luck running the statistical test in your head. So I will help you. Where the orange point is lower than the black, I will make the orange point magenta, bad, lower. Where it's higher, I will make it green, higher green, lower magenta, even though often in heat maps it's reversed, never mind. And where the point in the wild type, the healthy and the disease is not that different, I'll make it black. And I can then draw these little drop lines to kind of emphasize the distance. I can even hide the original data points, the wild type data points altogether, and just show you the points in the experiment, in the disease, where things are different, right? Look how quickly this draws your attention at what's important. I could then highlight different parts of the gene according to whatever scheme, and then I could even reorder these lollipops to show you the distribution and the number of over-methylated and under-methylated points. All of this depends on what the message is that you're sending. Okay, so before, during, and after, we've already seen dicer. So here's an example that Bang drew in one of the points of view, which is a great example. So here is a simple translocation, a gene fusion. He's drawing the point that that's a bad figure, and here's a better figure where you have this flip, and it's kind of a during, right? There's no before, there's an after, but there is only a during and an after. There's no before because you don't need to. You can kind of see that this arrow indicates some kind of a turn, as opposed to these arrows where this arrow says, look here, and then this arrow says there's action happening. So arrows mean now two different things. Avoid that. Notice what I can do is then change the background color of the chromosome area that's not impacted, or just focus on the genes. And depending on what color, what tone of gray I choose, I can establish, some emphasis on the gene itself. And then what I'm going to do here is, instead of calling it ABCXYZ, I'm going to go further and just go AB, because really a gene is just a name, doesn't have to be 3-letter. And I'm going to have the M dash be aligned with where the fusion point is, as opposed to here where it's kind of across two lines. Minor point, but everything is again aligned. So the visual representation of the fusion is aligned with the text representation. Okay, a figure has excellent Gestalt. So some of you may have undergone Gestalt psychotherapy, and I wish Gestalt psychotherapy was just drawing figures with good Gestalt, but it's not. So this is an example of Gestalt. There's some stuff you right away see, and there's some stuff you right away don't see, which is this gray square. So if this diagram was about the red circle, we're winning because you right away saw it. If this diagram was about the gray square, we're losing. A lot of figures in presentations are like this. Somebody will pop something up. It's like, oh, don't look over here, look over here. Like, well, then why did you show this? Okay. Speaks for itself. Okay, don't do one of these. Space makes groups. A lot of figures are about explaining relationships between things. Either these things are grouped because they're similar, these things are grouped because they're different to some extent. When you put space between them, these groups form. Sometimes space makes things hard to read, but usually space, so it's an effective grouper, and don't put space where it doesn't belong, but often space is all you need, as opposed to strong lines or boxes that separate things. Color is also a strong grouping element. In other words, things that are the same color are going to be perceived as somehow related. So don't reuse the same color, if you can, for things that are totally unrelated. This is why using a lot of colors can get you into trouble, because inevitably a couple of them are going to be more similar than others. And people are going to go, well, yeah, I guess there's 25 colors on this figure, so I can't use color for anything. I've stopped looking at color, which means color is pointless, so why not just do black and white? Be aware of the kinds of groupings that you should be creating, and be aware that the groupings you are creating may not be those. Does this have good Gestalt? Of course not, because we're in the Gestalt section. So does this have a good focus on the data, or is this distracting you with other elements? It's distracting you with other elements. So what if we just remove these colored bars and just leave the data? Great. Why is the data a different color? I don't know. Just everything is a different color. It's already a different row. So what if we just color the positive and the negative values the same color? And now you can suddenly see patterns very quickly. Again, everything that is being shown here needs to be there. If I remove something, the figure suffers. I just removed all the stuff that wasn't necessary. Does this have good Gestalt? Does this have a good sense of inside and outside, which is another Gestalt concept? This synaptic cleft doesn't really look like an outside versus this axon here and this, because it's just a line. It doesn't create a good sense of inside and outside, which would be created by filling in the neuron. And now look how the synaptic cleft is clearly a gap, a space between two things that are pointing to one another. You know, if there's, don't draw 3 channels when one is enough, right? Unless the cell really has 3 channels, and trust me, it does not really have just 3. By showing just one, it clearly doesn't just have one, right? So show the minimum number of things in the simplest way possible that is necessary to explain what you want to show, such as, do I need to show 5 vesicles? 6. Oh, one is enough, right? Like that's basically the main story. Otherwise, we just get lost. So look what happens when I start removing the fill, right? This inside and outside sense is poor. But look what happens when I remove the neuron outline altogether. The labeling is designed in such a way that it still makes quite a bit of sense. Everything is aligned. The context is missing, but I don't need the outlines of the neurons to keep things together. Okay. Good Gestalt or bad Gestalt? Obviously bad Gestalt. Everything is all over the place. I don't know what's going on. So is there a good sense of inside and outside with cytoplasm nucleus? No. So what would I do? Draw the membranes, provide some kind of a flow to the steps, throw in stuff. And now to provide an inside and outside, I would fill in the nucleus slightly darker than the cytoplasm, provide colors only where stuff is downregulated, upregulated, put the legend next to the colors. And then lots of room left for text, and everything is drawn in as simple a way as possible. And right, TI crystals, they're just rounded rectangles. Everything is a rounded rectangle chromatin drawn in the simplest way possible. I encourage you to do that. Especially in posters, try to bring text into the graphic as much as possible and leave out these kinds of notes beside the graphic. So here's a poster. Let's look at it a little bit closely, right? Doesn't matter what is going on, but you've seen this. You've probably made this kind of graphic, right? There's a paragraph. There's a couple of points. There's a graphic, and then there's a zoom in of the graphic. So you're showing the same thing twice with some notes below that actually describe what's going on here. So here's a 1, 2. Here's 1, 2. Where's 3? Where's 3? I don't see 3. 3 is here, right? So it takes time, particularly because 3 comes before 1 and 2 in the graphics. So why is 3 up there? What I would do is I would just draw this and annotate it as I'm drawing it, a single figure. And now I have the aims of the work actually inside the graphic, which is, I think, a much better way of doing it, because you're putting the aims in context of what's going on. Here's a bacteria, it goes inside. I want to know what's going on. And here is key observations as opposed to conclusions, right? And then cytosol nucleus, right? Inside and outside, very much outside, inside, more inside. Trying to do this kind of thing. Quiet personality. Don't think that by adding stuff into the graphic willy-nilly, you're gonna spice it up and you're gonna make it more interesting. Unless you're incredibly talented and you've done this a long time and you're doing it with an objective sense of a certain amount of dispassion and and no ego involved, you might do a good job, but often you won't, because you're just not aware of all the elements that are going on. So leave the personality for something like the title page. As I say when I had a really dull title page. So here's a title page of a talk. So University of Sydney has a really nice branding, color, bright orange, gray. Left side, punchy. Right side, the dullest image you can imagine of the poultry unit, right? Just like the worst figure compositionally, but also completely uninteresting. So what about just look up some images of chickens, drop them in, fill the page with white and orange, create some personality, create a scenario where I don't know what's going on, What is she doing? What is he doing? And then just move on. Don't talk about the chickens. Here's a presentation slide for snails. This is exactly what a snail looks like. Why am I looking at the snail? I've learned nothing. Instead, why not show some shells, shell snails, right? I just learned something about snails. Wow, that's amazing. Do you need to put your name on the title slide? If everybody knows who you are, you don't. Oh, this happens all the time. A beautiful image hidden and made transparent slightly. And then a title, big title with a box on it covering the image. But the image is amazing. Look at these guys fixing some instrumentation in a pontoon floating in a giant tank of water. They could be at the center, which gives you a different sense, or they could be at the top, which gives you the sense of depth. Pick one, put the title below, and make a strong statement. Be artistic in this way, which has, you're not taking a chance with data here. You're just setting the stage for your talk. And then you could pick one of these, right? This is a different feeling. And kind of, you know, if you like composition, if you like photography, you like these kinds of geometries, you realize you have a slightly different feeling and response to each of these. Be sensitive to that, and chances are your audience will too. So those of you who sent in some work, thank you. And I'm just going to take a bit of time to look at the redesigns, which are largely going to take all of those points that I've covered. And of course, I don't know what the figures mean, and I didn't have a legend, etc. And I didn't talk to the submitters. If I make any error, I'm sorry. So here is a
Martin, just before you start, maybe I could just give a quick reminder to the audience, because I forgot to say at the start that we have also a question answer box at the bottom, and so please feel free to submit some questions there, and we'll get to them at the end. There's one now there, Martin, but I guess we can leave for the end if you want.
Sure. There'll be plenty of time for discussion, which I invite you to participate in.
Thanks.
Okay, so this is I know exactly. I look at this figure and it's basically, I know what the person is thinking. There are these three runs that happen at perhaps, and the peaks happen at different positions, some chromatography peaks. And so the runs are not aligned. They're kind of staggered because the peaks are in different positions. And then you do some kind of an alignment to try to figure out which peaks are which across multiple runs. And these alignments are indicated by these dashed lines. And my question right away is, does this need to be at an angle? What is the benefit of not aligning the axes? What if the alignments were more vertical? What if I just moved stuff around and I did something like that? The alignments, it's still clear that I need to shift things, right? That the peaks are in different positions, but now there is less horizontal movement and it's more about the vertical movement. There's a much stronger sense of alignment. I had no clue what that check mark meant. I was a little worried, but I was thinking, oh, it's look at that. We see these three peaks here. We see these three peaks here. We see these three peaks here. They're kind of in the same order and roughly the same proportion. That's a success. I'm just going to take that as the story, okay? Now, if that's not the story, then you should realize that that's what you're telling me. You're actually leaving me kind of helpless to try to figure out what could this possibly mean. So that's what I thought it meant. So how can you take this a little bit forward? Well, you could remove the vertical axis that I needed. Nope. You could do this kind of thing. What is exactly happening in this method, right? There's lots of room for annotation, but here I follow a series of peaks. And by doing this orange, blue, green, notice I've changed to slightly less saturated colors. I'm kind of telling you that I'm performing some calculation based on the peak height, something like this, right? And then I can indicate the alignment this way. Everything is kind of vertical. There's you could do put lots of text here if you need to. Notice how much I can pack in on a slide in terms of text if I'm giving a presentation. And then finally, if you are drawing these kinds of curves, just go and download a normal distribution SVG line, drop it on your artboard, and then just change its shape, height, and width. And they'll, of course, these curves maybe are not expected to be normal, but it's okay. They have a pleasing shape and everything is uniform. And it's really not about peak shape. necessarily. It's more about position, because you're trying to say about alignment of position. So even though there's a lot of things that are varying on the graphic, pick one that's key to the message and then encapsulate the detail. Great example, timeline, right? What can I remove from this graphic? Are there visual tropes here? You could probably tell that there's a visual trope that I try to avoid as much as possible, and that's this zoom idea. Look what's in the syringe. And so we have this crop, we have this thing in a circle, and then we have this crop, and then we have the same thing, and this crop keeps following the syringe. The syringe is at different angles, it's a different color, and like, I know what's going on, right? I don't need this to be orange, pink. I don't need this to be blue. I don't really need the outline. I know this is a series. Now this is telling me look this way. This is telling me look this way. Try to simplify things as much as possible. So first thing to do, you Google rat brain icon, and you might find some icons of rats and mice. Here they are. They're free to use. Pick one and just use it. Don't use a complicated image with like eyes and everything. Just don't need to. Here is a rat or a mouse. We're doing something to the brain, so I'm just going to draw in a very simple brain. Yeah, I probably messed up the anatomy, but whatever. Here's a very simple syringe, which I'm going to use. And then I'm just going to do something like this, where I'm going to say immunization day 0, and this is what I'm stuffing in. It's right above the syringe. There is no mistaking that that's what's in the syringe, right? It's yellow, meaning there's something in there. It stands out quite a bit, notice, even though it's on top of white. So they're both bright colors. If I need to say that it's being inserted in, injected into a particular organ, I might draw the organ like this with the label. If not, doesn't matter. Stereotactic injection here, I decided to not draw this apparatus. I'm just gonna say that if I draw XYZ axes, okay, right-handed coordinate system, and I say stereotactic, the person knows that this is fixed in space. I'm putting it right into the cerebral cortex, which is what I assume this in CC means. If not, I'm sorry. I would not say in CC. If it is cerebral cortex, I would say into cerebral cortex. Acronyms in titles, ugh. And then brain extraction. So what does that mean? The mouse is gone, the brain is there. Instead of just showing the brain, what is happening? Continuity. I have the same organism shown across. And the brain is always there, and that's the focus. And the little dots on the line, timeline, reflect kind of that orange is the important color. And I might add more, move the titles of the step below the day and have more annotations there. Look how much detail I can pack in by this, using strong colors like orange to identify the things that are important. Notice that here, I don't know that I'm going to be dealing with a brain, right? Like if I just look at the first graphic, well, I don't know why you're doing this in the mouse. I don't know what the end goal is. Whereas over here, it's like, the brain is highlighted. So it's got to be something to do with the brain. I think that's a good idea. Here's another graphic. So what would I do first? I would try to make the hydrogel image a little bit bolder. So I would make the lines, the cross-linking or whatever it is, stand out a bit more. Hydrogel, I'm thinking it's in an aqueous solution, so I'm going to make the background a bit more blue, and the lines will just be white. White is a great way to draw something that's different. It's the lack of ink, but it stands out more. The drugs are going to be bigger circles, drug 1, drug 2, etc. Room for annotation. Now, then I'm going to Google icon of human brain, and I'm going to get this, and I'm going to use that as my graphic. Okay, I'm not an illustrator, so this is quite rudimentary. But the point is, I'm going to avoid this crop. I'm going to first talk about the hydrogel thing here and set the stage. And then I'm going to say, and here's how it's inserted. Instead of doing this crop thing, which you already can tell I really don't like, especially with this gradient and how do I point to the syringe and this complicated syringe. So here's the syringe. Notice the little Christmas tree lights in the syringe, same lights as over here. So it must be that the syringe has that. Here's the pod, or the thing I guess you're injecting it to, and then this is placed on the head. I couldn't figure out where this pod was. Is it on the scalp? Is it under the scalp? Is it under the cranium? I don't know. Is it crossing the blood-brain barrier? I don't know. So I'm just gonna guess that it's under the cranium, okay? Maybe not. But here it's totally not clear, right? Where is this in terms of depth? So I provided a little layer, and I said, here's the pod right under the cranium. And here's maybe some description of the reasons why that is the case. Okay, last example. So posters. Posters are notoriously difficult. And the other thing, the most difficult, the poster is the second most difficult. The most difficult thing is graphical abstracts, because it's a tiny space and you don't have a chance to screw up because you can't fix your errors because there's no space. Posters, there's generally lots of space. You can generally say too much. And it's difficult to orient yourself on a very large canvas, right? So what makes posters easy to make is if you just dispense with the visual tropes, the boxes, the weird alignments, and just lay the text out the way you would imagine if you were looking at a newspaper. You'd be surprised how much organization this provides and how it relieves you from the burden of, I don't know what to do. I'm a scientist, I'm not a typographer. So let's look more carefully at this poster, and I'm going to give you my ideas of where things should change. This is not a statement about science, of course, right? None of what I'm saying is about, is the science good? I don't know. I can't know. I mean, that's another process altogether. But how could I make this poster faster and snappier to read, and also provide you with a scheme of thinking about posters that will translate to most posters? And being sensitive to the stories in the poster and to the relationships of things on the poster, and again, trying to borrow from this tabular idea of aligning. So I've seen posters like this, and most people have the same default settings. They will generally put things in boxes. The center alignment of the title is different, and I don't think it works. I think you have to be very careful when you're aligning things centrally, particularly when there is ragged ends and when it's difficult to propagate that central alignment all the way down the poster. Okay. I would dispense with all colors in the background, even if it's your institution's template. I would fight this fight where I stop using the institutional template. I, of course, pay attention to the logos and provide appropriate acknowledgements, and maybe use the branding color for headlines, but I would dispense with a template and just see what happens. Ask for forgiveness instead of permission. I would also avoid the bolding of words. The sentences are so short that I would try to establish the theme in a slightly different way. The main data section is these pluses. I was thinking, what are those pluses? Oh, and I got this sense, like, I guess it's some kind of a activation Z score. It's just telling you IL-4 is activated to, a light orange, and P5 to a light blue. And the pluses don't really mean anything. And so keep that in mind, that here you're showing data as a heat map, fair enough. And here you're showing the same data, but in a different format. And there's also a missed opportunity here of aligning these with the order of the mechanisms, the genes in the heat map. So I would reorder this. I would not use red and green heat maps. They're not colorblind friendly. I would go to Color Brewer and orient myself around some color palettes that are better for color blindness. And if you are using software like R, first, God help you, just kidding. And second, use the Viridis color scheme, maybe even something like Plasma. Don't use Turbo. So there's lots of other color palettes that are better and are more accessible. Okay, and then finally at the bottom, the conclusion, which are the important things. So notice here that there's that center alignment, and I don't think it works really well. So we'll fix that. You don't need to say references. There's only one reference. It's clearly a reference. If there's only one, I would bring it closer to where it appears. And then, okay, the acknowledgement. So this is how I would start. Basically, I just strip everything away. And I try to think about the active titles of sections. So instead of saying introduction, conclusion, etc., I would say, okay, my intro will be this PMS mat train. I'm going to describe that. That's my intro. My objectives would be more of an active title. You know, how does something, some kind of a question. So it sets up a narrative right away, because objectives doesn't really tell me anything other than what I'm about to read is an objective. Why not just tell me what the objective is right up front? Conclusions, I like the conclusions at the beginning and the methods at the bottom. And that's because people generally want to do like, what is this about? What did you find? And it's like, oh, that's interesting. Let's see how you did it. That typically is the second question. People generally don't say, well, don't tell me what you found. Please tell me about the experimental apparatus. It's like, nobody cares, because what if you didn't find anything, right? Okay. And then in the, we'll put the data here, and I'm just put point 1, point 2, point 3. Again, room to put your observation. So here's some text, right? It's very simple, just like paragraphs you would see in a newspaper. And what I'm going to do here is I'm going to have these rows of prediction of regulated biological functions. There's another predictions here, factors contributing to, et cetera, 1, 2, 3, yellow, highlights, bold. Then I'm going to drop in the table that will create a section for the oligodendrites and the neurons and the treated iPS derived, right? Because there's these two types of cells. So I have this table, and now you could expect, I hope you're anticipating the data to appear. I didn't have the data, so I couldn't redo the graphics, but you would drop the heat maps here, and there's lots of room left. There isn't this sense that I have packed the poster in completely tightly, right? If there's more information, I could find ways to arrange it. This is a good feeling that the reader has when the reader feels like there's lightness, there is space that creates groups, right? Good Gestalt. If I just remove everything and keep the text, it's nicely laid out. It has structure. If every element has structure, then the whole thing holds together well. So here I would only bold the acronyms because they're being reused as opposed to the terms. Notice what I've done over here. Remember those pluses on the left and right side? I've rearranged things so that the column names of the heat map correspond to the same data points below, right? I probably would have adjusted the stars because everything looks significant, right? It's all significant, everything has a star. And so significant value, so I would say what is shown is significant as opposed to having the stars. You know, this is in hindsight. And then tuck in the neurons here. Those were good. The graphics were good and simple. This kind of, you know, up SOC stand, down TNC leads to high OD. Kind of put that as a title, as a heading to this heat map to basically tell you what I'm seeing, what I'm expecting to see, and then the details would be evolved kind of in the text below, okay? And all the headings now are acronyms, but because you've introduced them, it's fine because they're really, really, really long names. And then the methods go at the bottom, right? The reference here and the acknowledgements. And I don't need to say acknowledgements because it's clearly an acknowledgement. I don't need to say references. I would probably fix this figure, but I just ran out of time. You know, so boxes would be removed. Notice that, is there an axis? Yes, there is. All of this serial processes leads to the equipment. Don't show equipment, just tell me what you're doing. I don't really need to see equipment unless the poster is about the equipment. So I'm going to leave you with a couple of ideas, right? I hope, at least. So make conscious choices when you are placing things on the page. in the sense that everything has a reason to be where it is, and form will follow from function. Do not think of form first. And then finally, I will quote here from The Art of Motorcycle Maintenance, which is a book, if you have not read or have read, you should reread, that talks about classical and romantic thinking. And this idea that classic thinking is straightforward and adorned and emotional, and that it is not an aesthetically free and natural style, it is aesthetically restrained. Practice aesthetic restraint, and I hope that with that, you will create better explanations and your readers will, I think, appreciate it. Thanks so much for your time, and I am happy to open up to questions and try to address them as best as I can. Thank you.
Okay, fantastic. Thanks very much, Martin. Many thanks for this fantastic talk. I think it's really eye-opening, and yeah, I really feel like this is one we can all really benefit from. In particular, I think it was great that you put so much effort into these submitted figures. I mean, I think this is really specific advice and really direct to our audience.
I think that's the only way to demonstrate through before and afters the benefits of some of these rules. And so if anybody tries to teach you graphics, I think, without taking the time to show you how they can be made better, how your writing can be better by rewriting your writing, it's never clear whether the rules are easy to implement, because rules can sound great. You know, the 10 rules to life, oh yeah, they sound great. Implementing them, on the other hand, right? Good luck. Often in the wild, you have to have an awareness of a lot more and sometimes break the rules. So I wish more people sent me stuff, but I understand it's a little scary. It's okay. It's okay.
Okay, terrific. So then I would hand over to Yansheng and Tech, who can mention some of the questions in the Q&A.
Oh yeah, I see them now. So yeah, let's go through it. Maximum number of colors recommended for a graph. Colorblind readers, yes, you should take colorblind readers because it's free. You just pick a color blind friendly palette, and it isn't less visible to those with proper color perception. So Brewer palettes, pink, yellow, green, that's a nice one. So magenta, blue, nice. Just avoid red and green. What is the maximum number of colors? So, you know, I'm just going to say 6 to 8. After that, it's really tricky. I have a bunch of color resources on my webpage for palettes for color blindness. Check those out. How do you differentiate between visual tropes and a shared language? Yeah, I know that's a difficult one. And sometimes I break it and I piss people off. If you feel as a subject matter expert that the shape is not related to the thing that's being discussed and it's too complicated, it's probably a visual trope. If you're talking about an abstract notion of a chromosome, let's say, right? A chromosome, I don't need to draw it. But if you're talking about the structure of the chromosome and the fact that it has a centromere, then I do need to draw it. So the point is, what is it that you need to know and at what level of detail for a given message? If it's just protein XYZ, I don't care how big it is. I don't care what the three-dimensional conformation is, because you're just telling me about protein XYZ and it goes here and then it goes there. However, if you're talking about the structure, well, then yeah, show me the structure. So use your judgment. And it's kind of like when you're telling someone an important story, right? Something happened, very important. You're going to talk about the key elements. You're not going to talk about, oh, and by the way, I had, you know, croissants for breakfast, that kind of thing. So the croissant is a visual trope. It's the thing that people just do. And generally, most things are visual tropes. Assume it's a visual trope unless otherwise. A software to modify figures. So I use Illustrator, but you could use whatever you like. And I don't want you to think that, I want you to think about the software and the graphics as two different things. Do not think, I don't know how to do this, and therefore I won't do it. I don't know how to fix, I know how to fix it, but I don't know how to do it in software. I don't know how to draw a red square, so I don't want to draw squares. That part is really easy because you could YouTube how do I draw squares in Illustrator? And there's like 1,000,001 tutorials, but there aren't any good tutorials about how do I fix my scientific figure. So the software is a toolbox. Learn something really well. Illustrator is not the best. There's Affinity Designer, which is cheaper, but it's the thing that's out there. And if you take a couple of years to get to know it, it's actually not that complicated. You certainly don't need most of the features. You will become very proficient at it, and you should definitely get out of drawing things in PowerPoint, please, 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 because it is keeping you suppressed under this veil of inadequacy in the software. There's no layering. I can't turn on layers and look, oh, so are my axes aligned, or is my text aligned?
Can I follow up on that one, Martin?
Yeah.
Actually, so you mentioned OR a few times, and that very often the default plots in OR are less than conforming to your principles. Yeah. So, I mean, is just to follow up on the software question, is your workflow to say make the plot in a software like OR and then take it to take the SVG to Illustrator and then make it nice there? That's the idea.
So it for the final publication ready plot. Okay, a paper is an important thing, and it's the product of thousands of person hours over many years. Take a day or two making the figure perfect, which means minor adjustments, careful adjustments, don't move the data points. So export to PDF, adjust them in Illustrator, make everything consistently sized, be aware of the journal requirements for figure size, be aware of font sizes, all of those technical details. There's a bunch of them there, which I didn't get into because I think that those are dull and easy to look up. For lab meetings, don't spend 5 hours on a plot when you're just going to show it to experts that are working on in the guts of the data. Then that's totally fine. And then just maybe figure out how to remove the gray background in R if you use ggplot and something like that. But I touch everything that comes out of R if I'm going to show it, and it's actually not that difficult. Illustrator gives you lots of opportunities and ways to manipulate things and move them around and organize yourself. And it's really a good exercise. Preferred font, right? Okay, so Helvetica and Minion, done, right? Unless you want to be a typographer. If you want to be a typographer and you really love typography, read Bringhurst's Elements of Typographic Style. And the only book you need to read, because it's written like poetry about typography, and it gets into the fact that letters have vitality and you have to respect them. It's fantastic. Most people don't have Helvetica and Minion. So, Arial and Georgia, you probably have that. Just stick with that, okay? And then, because the fonts are capable and they're fairly neutral, and that's all you need. So I noticed that I used Helvetica Now for the poster. That could have been anything. I could have used serif for the copy, which you could choose. So the letters have these little feet, right? So for headings, you could use sans serif, no feet on the letters. For copy, the little feet help your eye lead along lines. That's usually a good thing to think about. Fonts are like clinical procedures. They need to be clean, they need to be tidy, they need to be competent and get out of the way for the content. Recording, I don't know if it's going to be recorded. Most favorite font, okay, I just answered. You mentioned you like the focus effect with the dotted line. Do you have examples? Yeah, so a lot of times when this idea of the cropping, like here's a small version of it, here's a bigger version of a part of it, and it came from here. Sometimes all you need to do is show maybe a little circle in the small version of it, and the big thing is also a circle. It's clear that circles are related. You often do not need to join the things together, but here you have to use your judgment. And if you feel like you're not certain, proceed very slowly. This idea of drawing less should be approached carefully so that you don't accidentally remove the important thing. And I mean, I've been fixing graphics for like 10 years, so I have an idea roughly of what I'm doing. but it takes a while to get there, and it takes many mistakes. Like you don't see all the mistakes, or people go like, you remove the important things. It's like, okay, lesson learned. Tips, programs to use. Okay, so we talked about that. No acronym abbreviations in the figure. Would it be okay to use less words? Yeah, so if you explain things in the legend, use acronyms, absolutely. The first time you mention an acronym, please say it. The journal requirement may have some rules about, at least Nature Methods, for example, forces us to define all the terms that appear in the figure in the legend, not just in the copy. Be sensitive to that. There are some acronyms that don't need to be acronymized, like in a figure like the cerebral cortex. I think it's not a problem to write it out. I think an acronym is really good for things like, very long processes. But if you're going to use it once, only once, do not create an acronym. I've seen this over in posters. We studied process X, Y, Z, and in brackets, the acronym. And then it's never used ever again. So it's like, why are you creating an acronym, a short version of it, if you're never using it again? Just be mindful of that. Zooming in on cluster-specific proteins in the middle, about biological protein networks. Oh yeah, networks are just another thing, the fuzzy ball, it's a pain. It's hard for me to make statements about it that make sense in a short amount of time. But there is where you really could use something like Illustrator, where you get a network out of R, perhaps, and then you can manipulate the salience of lines and focus on things that are important. Just be aware of the fact that if you're showing a network and it's going to be, say, printed or on the screen or on a slide seen by an audience in an auditorium, if they can't see it, it might as well not be there. If they can't make out the text, then why are you showing it? Are you just have a chip on your shoulder that I don't have complicated data? I need to show people that I have complicated data. Everybody has complicated data. Everybody has big networks, right? That's what we have. So always think about legibility, and always think about, is the thing that people are reading the thing that they should be reading, or are they hunting for Waldo? Okay, networks are hard. Add p-values in R Illustrator. Well, R can generate the p-values, I guess, and but I typically fix them up because I just hate exponential notation. 1.1 e minus 12, like that's a computer languagey thing. Just do the proper mantissa 10 to the power of, or better yet, minus log 10. Provide the base, because sometimes people use base 2. I've seen even base 8 used. So provide the base, do the proper notation, look up how it's written, don't italicize log, be very pedantic about the formatting of everything. So for example, sample size n, that's a variable, right? So that should be italicized. Most people don't go that far, but you should think about preparing everything with love, the way you would make dinner for your favorite person in the world. That's how you should be making science. You're making it for the world. It's important, right? You're doing it because it's important. You feel like it's going to make a difference. And if you're not, you should be doing it with love. And you should have that should maybe is your printed personality on the work. Copy of your slide deck will be shared. Biochemical. Present different types of biochemical assays beside bar charts. Not sure what the data is. There's nothing wrong with bar charts specifically. Be aware that they can stand out. There's quite a bit of ink in a bar, so that's good. They can be replaced with a scatter plot, though, if you don't need the zero line. But if you're going to have error bars on bar charts, don't do one of those things where I can only see half the error bar because one bar is black and one is white. Just use a lightish color so that I can see the error bars, specify what kind of error bars you're showing. And if you are showing error bars on bar charts, do not break the axis, because then it gives you a wrong sense of proportion between the height of the bar and the size of the error bar. How to prepare a cover image for general audience, which shows specific data. General audience, who is your general audience? I always try to view my audience as intelligent but easily bored. And so even when I'm talking to scientists, they appreciate when things are simplified and that the message is made clear. This is often what the public wants. It's just that you can't use the same acronyms. So this idea of the word protein, you have to be aware that maybe they don't really understand that that's an enzyme and that helps thermodynamic, activation. Cover images are, if you mean a journal cover image, that's a whole thing altogether. I've made a bunch. You can look on my website, and there's a bunch of descriptions of my approach. Things for the public require tremendous care and integrity, in that you want to show things simply, but you do not want to go down the road of really bad metaphors that present the wrong view of the internal mechanisms of a process, such as the genome is a blueprint. You've seen this metaphor, right? This is the worst metaphor in the world. The genome is not a blueprint. I look at a blueprint of a house, I see a house. I look at a genome, I don't see the phenotype in the genome the way I see the phenotype of the house in the blueprint. Okay, metaphor is broken. But when you say blueprints, like, oh, I have the blueprint, so I should figure out how everything works. Not so much. So just be aware that when you're in the public, when you're saying this is like something else, that you're actually making a good comparison. And if there is no good comparison, you're just going to say, this is not like anything you know, but it's important for you to get a sense of how it works. Here is a brief example. Okay. Style manual for formatting. Well, yeah, a lot of journals have style manual. Nature, I believe, does, but these tend to be technical things like line width and things like this. If you go to my webpage, there is a poster hospital and an graphical abstract hospital where there's a lot of case studies for posters and graphical abstracts. There are some rules there that I've encapsulated in brief form, which are a lot of what I mentioned today. You should look at that. How do you face resistance? Oh, of course. Yeah. Hive plots, they're hard to interpret. Circus, yeah, circus has its own problems, right? There's a lot of resistance. There's actually a lot less, and there's justifiable resistance, right? There's people, resistance sometimes is good, like freedom fighters, right? They're fighting for good things, and people bring up good points, and not everything works for everything, absolutely. But there is a resistance due to inertia and lassitude, and that is bad. And that's typically from seasoned PIs. I've been doing science for 40 years. Why do I need to do anything different? I have more papers than you. Great, end of conversation, right? Is this person making science with love? Probably not. Is this person a great writer? Maybe. Maybe they're awesome. Maybe they're the best ever. Or maybe they suck. I don't know. There's a lot less resistance with students who tend to see everything as an opportunity to learn, but do question critically. A lot of these rules that I mentioned should be broken in specific cases, but shouldn't be broken in the general case. Just knowing which one just takes practice. So resources for good icons. Yes, the materials icon project. I think Google has a set of, there's called a materials font, which provides you a lot of arrows, things like icons of flasks and beakers and things like that. If you're looking for an icon of a brain in a head, right? So you just Google brain in head icon, just use the word icon, or you pick the black and white option for image search, and you just look for the simplest thing that's royalty free. If you got a bitmap, you can trace it in Illustrator and create a very simple vector artwork, and then just use it going forward. Like I've been using the same mouse icon for 10 years. One of the ones I showed you is like a little chubby mouse, no eyes, so it's not very personal, and it's cute, and it's done. It's done. I do not need another mouse icon. In fact, anything more complicated than that, let's say if I put an eye on the mouse, this better be about the eye. This, if I put a detailed fur on the mouse, it better be about the fur. What's the meaning of the script icon at the center of your? Oh yeah, that's a floron. Oh, the little flower, the little shape. Yeah, it's a typographical symbol. They're called florons, and they're like garnish for separation of things. It's just it's quiet personality, I guess. Maybe. Sorry if that annoys you. Okay, that's the end of the questions. So I think I hope I've answered everything. How long have you ever spent on a single graphic? Oh yeah, like a week. So posters generally can take a long time. So like 20 hours of work to fix, not to make, to fix. To make, that person probably took longer. There are some graphics that are very difficult to, so you can recreate a graphic by having the data and saying, is this the right message we want to send? Is this the right scientific point to make? And then we have to redo the visualization, which is a totally different process, right? I'm kind of taking a graphic and I'm assuming, okay, for the message, I think the visualization is good. The encoding is okay. Mostly the encoding is fine, meaning, you know, is it a scatter plot, bar chart, etc. Like mostly the encodings are okay. It's all the stuff around the encoding that's tough, and that's often needs to be fixed. And often the continuity between panels that needs to be fixed, because that's what software won't do. Software is great at making a scatter plot, and then it takes no responsibility for what's around the scatter plot and how this first scatter plot is connected to the second scatter plot. That's the human part in the loop. So, you know, I would spend many iterations of a poster, particularly when I feel like there's a story here that I'm just not getting. This needs to be close to this, but I don't know how to do it. And it can take a lot of trying, because there's a feeling that I have that this can be better and I don't want to let it go. So, you know, there is this emotional requirement to have certain amount of resolution and peace on the page. If you have a bit of that and you're motivated by that, then that really helps. Death by heat map, right? So there is something called a luminance effect, which if you Google it, you'll be terrified, which is that we actually don't perceive colors the way they are in the real world. Our brain does processing, our retina does contrast processing. So the brightness of a color, and often the color, the perception of it is a function of the color around it. And this is not something you can reprogram yourself to unsee. This is hardwired into you, which means that in a heat map, you basically are almost never seeing the color in the heat map if you were to look at it under, you know, with the masking out all the other colors. Sometimes heat maps are the right thing to do, particularly if there's a lot of data and it's clustered and there's clear patterns, right? If there's clear patterns, like 1,000 samples and you get this block-like structure, okay, I see a block-like structure, there's something going on, now tell me what you see. If the heat map is like 5 by 5, then, you know, make it smaller, you don't need to have these big boxes, and then tell me more about what I should be seeing. Try to, you know, maybe separate rows and columns or the blocks in a heat map with space, no lines, just a bit of space to create some structure that tells the reader what they should be looking for. But I mean, you know, we can't avoid death. So if it's going to be by heat map, I mean, it's better than by a pie chart. And I'm glad nobody sent me pie charts. Okay, yeah, it's 90 minutes. I don't know if that's our time or if there's any more questions. I'm happy to try to hit them as quickly as possible. If there's questions you have, you could feel free to email. Widespread AI usage for data visualization. Well, you know, sure. AI, the human in the loop still needs to make sense of the story and the narrative, right? The human in the loop still needs to say, what should I say? How should I connect plot A to plot B? That's the part that AI can try to get. I mean, there's some things that you can fix automatically. And it'd be great to do it in code. It would be great for a library in art to look at a graphic and say, have you considered too many colors, too many lines, etc. Right? You've got elements that are not data that look like data. Maybe you should stop. That kind of thing. That kind of thing is probably low-hanging fruit for AI. But crafting a good story and knowing how to layer it, particularly, let's say, in a presentation, I don't have hope for that. And the reason why I don't have hope for it is that not that it can't be done, but then everything would sound exactly the same, and there would be very, very little room for personal expression and narrative that is your style. And I think in science, you know, we're plagued by the fact that we're studying the physical universe. And if we don't study it, someone else will, and they will observe the same thing and probably come up with the same model. If Einstein didn't do relativity, somebody else would have. I mean, quantum mechanics was discovered by two people, created by two people, Schrodinger and Heisenberg, in different mathematical formats, but exactly the same calculations, just Schrodinger kind of won. And that's what we know. We don't know that Heisenberg did the same thing. So where does that leave you as a human being with, you know, personality? If the science demands that you're sanitized and objective, well, it's in the little story. It's in the way you inflect. It's in the way you string things together. So AI is, you know, automation, but there is still a reason why people are needed, is because that's what makes us interesting. And we just have to figure out what makes us interesting, and the rest we can outsource to AI. Lots of questions.
Yeah, so seems that
sorry, right, we're on time, right?
Yeah. So I think that's great, Martin. We can all feel your passion, and thanks a lot for the thought and tips and insight. You barely need any panelist because you answered all the questions. We also enjoy the dynamics. It has been 25 questions, I think you answered in just 20 minutes. I would encourage all the people who we cannot provide the answers on live to just send Martin an email, and we will make sure that the videos and the slides are available. So there is one announcement that ETC wants me to provide, which is a reminder or announcement for our following webinar. So we are so proud of this dynamics in this academic writing. So the next third lecture will be from Rudy episode. So I don't think Rudy need any introduction to this audience. He's so well known, and Rudy will talk about the proteomic paper writing and publishing. And he kindly agreed to share his views and experience regarding the scientific writing, publishing, scientific communications, and the relevant discussions will be when, why, and where we should publish papers, and how to reply to reviewers, and what elements are essential for writing papers as a whole or as each part. And the importance is about the time, right? So the time is March the 2nd. So please mark your calendar now, and it will be the same time. So basically 4 p.m. CET, 10 a.m. EST. And please mark your calendar. And maybe Ben and Tech, you can provide more conclusion for this.
No. Yeah. Thank you, Ben, and thank you, Martin, for talks. Very inspiring. And this is a part where I always overlook at the graphic design as well as the right presentations of data. And now I sort of outsource things to biorender. I wonder what's your take on that. But anyway, I enjoyed the talk very much. I'm looking forward to the next talk by Rudy. Thank you, Jensen.
All right, thank you so much. Thank you.
Thank you very much, Martin. So Liken, I think you can close the webinar if